World War II rages on, and as armies clash around the world, a second secret war is underway. It's aimed to be the first to crack the codes of their opponents. For if one side can decipher the communications of their enemies, you can not only know what they're doing, but what they will do, and so win the war. So how did this mathematical race lead to the invention of the computers we use today? Find out next on Quirky Science.
A computer is actually a very simple concept. It's just a machine to manipulate data according to your instructions. But how did we go from this to those sleek, high-powered laptops you see in modern houses? How did we learn to talk to computers, and how did we teach them to talk to each other?
The oldest known precursor to the computers of today was the Antikythera mechanism, discovered by sponge divers off the island of Crete in October of 1900. Deep within the wreck of a Roman ship believed to have sunk over 1800 years earlier was a curious wheel, whose significance would not be understood for decades. In fact, only recently have scientists come to understand how it may have worked, and that it was, in fact, an ancient Greek mechanical computer, built in about 150 BC. Designed to calculate the position of the sun and moon, as well as to calculate the dates of solar and lunar eclipses, it was so sophisticated that it would take some 1400 years for another machine of similar complexity to appear. Then there was the fantastically named difference engine, the brainchild of British mathematician and inventor Charles Babbage, who conceived it in the early 1820s. It was a massive steam-powered mechanical calculator designed to print numerical tables, shortcuts if you will, that allowed mathematicians to better and faster calculate mathematical functions. What Babbage observed was that these tables, when created by humans, had an unacceptably high error rate. So he decided to find a way to calculate the tables mechanically. He attempted to build this machine over the next 20 years, only to have the project cancelled by the British government in 1842, who had finally grown tired of waiting. Yet, instead of giving up, Babbage turned his thoughts to creating something infinitely more difficult: an analytical engine, a mechanical computer that could solve any mathematical problem. Unfortunately, despite drawing up detailed plans for their construction and working on several prototypes, by the time Charles Babbage died in 1871, neither of his machines had ever been built. Only in 1991 was his difference engine built based on his plans, and it worked. A fitting epitaph for the man called by many the father of the computer. So what was the key that made Babbage's computers work? Well, his analytical engine used punch cards, pieces of paper on which a hole was punched through, and a creation that would help operate computers for decades. For punch cards marked the beginnings of a computer language. But this invention predates even Babbage's engines. They came about thanks to the efforts of a French silk weaver and inventor during the early 1800s. Joseph-Marie Jacquard was struggling with the slow pace of his silk production. Already greatly in debt, he was determined to find some way of automating his weaving, but also increasing the intricacy of his designs without losing more time. His solution? To create a machine which could read patterns of holes in a string of cards, which in turn would automatically control the threads on his silk loom. By 1812, he was successful beyond his wildest dreams, and there were over 11,000 Jacquard looms in operation throughout France.